Howdy, HL, it's Miss Kosh. I wasn't sure that my previous videos that worked through those 4 examples, I wasn't sure if they showed you enough on how to do it with the calculator, because I will let you use the calculator, and I imagine that IB will as well. So what I've done, what I want to do right now is to use the CASIO. I don't have, well, I have the TI from when I was in high school, but I don't think I have a TI that I can show you with. So Google it. I would definitely use the reduced row echelon form that I was talking about, well, that I will talk about if you have a TI. So, or come ask me questions. If you bring me the TI, then I can talk you through it. Okay, so let's see. First of all, we can always go menu. We can come down to equation. And we can do simultaneous, and we have 3 unknowns. Oh, let's hit clear. So I don't remember what was there, but let's say I'm looking at number 1. I can take all my coefficients and put it in here. -3, and then 4, 1, 1, -1, -1, -1. Sorry. Okay, I hope I typed that in correctly. And so it's very obvious when we get a point that it looks great. Okay, the problem is what happens, what happens when it's a line. So here I'm going to jump to number 4. I'm looking off of my computer screen. You should have these notes somewhere. So I'm just typing away. Hopefully I'm accurate. We'll find out in a second if I didn't type them in correctly. Okay, so my calculator here gives me infinitely many solutions, but I'm going to, which means that my 3 planes are all intersecting in one line. But I'm going to want more than you just telling me that there's infinitely many solutions. I want you to tell me what is that solution. So there's a way that our calculator can help us with that, and I'm going to show it to you in a second. Before we move on, let's see real fast what happens when we have a situation where there's no solution. So I think number 2 on that worksheet was no solution. We're about to find out. Yep, I've done that. Okay, -2, and then there's a 3. Get rid of that. Yep. All right, stumble those who run too fast. Is that the Shakespeare reference? Okay. So here we go. So this tells me no solution. That's great. I would accept an answer of no solution. That means that your 3 planes, well, I'd want you to tell me more information. 2 of them are parallel, and the 3rd one doesn't intersect, intersects each one of them, but doesn't intersect both of them because those 2 don't intersect. Or there are 3, they kind of make that triangle shape we've described before. I'd want you to tell me a little bit more information, but typically no solution is a good enough answer. Okay, so what we need to do, though, is we need to figure out what we should do if we get that infinitely many solutions response. So what I can do, you'll notice is MAT on the calculator, that's matrices. So if I click that, I have gone through and I put in problem number 1, 2, 3, and 4 here in those matrices. So this first one, I plugged in this one, so I don't have to do it again. Then it's number 2, number 3, number 4. So what I want to do is I want to exit out of here. I can go matrix. Nope, I lied to you. This only lets us change them. So let me just show you. If I wanted to, I'd click on it and I'd have to tell it I want it to be a 3x4 matrix, and then it'll take me into there when I hit enter again, and I can type away the stuff I want. Okay, well now we have a matrix E. So let's exit out of here. What I'm going to do is I'm going to go to option. And then here matrix shows up again. What we want is we want to take this matrix and put it into reduced row echelon form. And that's where we take reduced row echelon form, basically gives me this 1 0 0 0 1 0 0 0 1. That's the identity matrix with an A, B, and C right here. Okay, and this would tell us this is our X, this is our Y, this is our Z, and this is what they're equal to. And so this tells us that it would intersect, these 3 planes would intersect at the point A, B, C, because our X is equal to A, our Y is equal to B, and our Z is equal to C. Okay, so that's what we're trying to get it into. And so what I did back here is I came to option, And then I hit option, there it is, and then there's matrix, and now I can come over to where I see this RREF, reduced row echelon form. And I know the TI has a way to get there. I don't have one to show you, so go figure it out. So reduced row echelon form, what do I want to do reduced row echelon form on? Well, I want to do that on matrix, and now I can hit, I can do matrix, and then I can hit alpha A, okay, so there we go. And notice this one we said a minute ago that it's, that those three, the number one, they intersected in a point, and sure enough, x is equal to -4, y is equal to -3, and z is equal to 0. So this is intersecting at the point -4, -3, 0. Okay, so let's see what happens when I want to do, let's walk ourselves through it again. I think if I come back here to, let's see, matrix list. Okay, I don't remember what that does. Let's just not do that. Let's do B. We said B had no point. And so what we notice here is I get a false statement. I get that 0 equals 1. That's no good. That tells me, well, and this -1 kind of shows me that something's glitchy. But 0 does not equal 1. There is no solution. Okay, I can come back here and change that to alpha C. And now on this one, here's one where we had gotten the fact that there were infinitely many solutions, but doing this reduced row echelon form gives me more information. Notice down here I have a true statement. I have that 0 equals 0, which is great. That's how I know I have infinitely many solutions. So what I'm going to do in this particular problem is I'm going to let, typically this is easiest to say, let z equal t. Okay, then when my final answer is going to be in parametric mode, I'll have my z equals t. Oh, you can't see what I'm doing. There it is. So we're gonna finish this off as we go. Okay, so what I know from here is that my 1y minus 1/5, what is that? Well, z, but this is now t, is equal to 1. Okay, so I skipped the step to say that this is y minus 1/5 x equals 1. Well, x, I keep saying x, I mean z. Let me try this one more time. Y minus 1/5 z equals 1. So my z equals t. I'm going to substitute that in, and we're going to go from there. So y is equal to 1 plus 1/5 t. Okay, or I could say y, coming over here, y is equal to 1/5 t plus 1. Now I need to do the same process for x, and so here my x, I'm sorry, I should have zoomed out more, but you know, it is what it is. Okay, so on this one, here we go. X plus 0y plus 4/5 z, which z is equal to t, is equal to -1. Okay, so therefore x is equal to -4/5 t minus 1. Taking that over here, x is equal to -4/5 t minus 1. So what you may notice, this is in parametric form. If I wanted to put it into, this is the equation of a line, if I wanted to write it in going from parametric to vector, I have my position vector times t times my direction vector. The position vector was these values. Well, there's nothing here, so -1, 1, 0. And then it's t times -4/5, 1/5, and 1. Okay, and maybe that's annoying and I don't want to deal with this, so I mean, it would be parallel to it to multiply everything by 5 and to say that I had x, y, z is equal to -1, 1, 0 plus, it would be a different, you'd have to use a different, well, the t value here and I could plug in something, I would have to plug in a different something to get to the same point over here. Let's call it s but I could say -4, 1, and then 5, and that would be another way to write the equation of that line. So if and I'm likely to do this to you, to make you write this on a test where all of these are integers, and so that's how you would do them. All right, good luck, go practice.